It was a dark winter evening on December 22, 1999 at London Stansted Airport. A Boeing 747 cargo jet, one of the most capable freighters in the skies, was cleared for takeoff. Moments later, the aircraft vanished into the clouds, and within less than a minute, it was plummeting toward the English countryside in a deadly, uncontrolled roll. All 4 crew members, seasoned aviators, were killed. What caused a massive 747 to fall from the sky almost immediately after departure? This is the unsettling story of Korean Air Cargo Flight 8509. Flight 8509 was not a passenger flight. It was a cargo run, a final leg from London Stansted to Milan Malpensa, following previous stops in Seoul and Tashkent. The aircraft was a Boeing 747-2B5F, registration HL7451, built in 1980 and with over 83,000 flight hours logged. On board were 4 crew members: Captain Park Dok-kyu, a veteran with thousands of hours on the 747; First Officer Yoon Ki-sik, less experienced on the type; Flight Engineer Park Hoon-kyu, experienced and respected; Ground Engineer Kim Il-suk, present for routine oversight. This should have been a routine departure. Instead, it became a disaster that exposed deep flaws in maintenance, instrument reading, and cockpit interaction. On the previous flight leg, the captain's attitude director indicator, the instrument showing pitch and bank, was unreliable in roll. The flight engineer recorded this issue in the technical log and informed the ground engineer. At Stansted, engineers attempted a repair, but they only replaced a connector on the ADI itself. The deeper problem lay in the inertial navigation unit that supplied data to that same ADI. Though a test button made the ADI appear to work, the underlying INU fault remained untested and unresolved. When maintenance handed the aircraft back, the ADI selector was returned to normal, meaning the captain's primary instrument would again be driven by the faulty INU. This was a critical failure point, a ticking bomb inside the cockpit before the flight ever began. At 1836 local time, Flight 8509 was finally cleared for takeoff from runway 23. At first, everything seemed normal. The aircraft climbed into cloud, merging with darkness. But shortly after liftoff, as the climb continued, the ADI's comparator alarm began to sound, indicating a disagreement between the captain's instrument and the alternate indicators. The captain's ADI was now feeding him false information. Though the first officer's ADI and the standby attitude indicator showed the correct bank angle, the captain's was telling him the wings were level when they were not. Repeated comparator warnings sounded, a clear alert that the instruments disagreed. The flight engineer called out warnings.
Bank is not working. Bank! Bank! Standby indicator also not working.
But the captain, convinced by his own faulty ADI, continued to fly. He maintained a left bank. As the bank angle increased, the left wing dipped ever lower. Within less than a minute after rotation, Flight 8509's wings scraped the ground. The bank had reached almost 90 degrees. The nose pitched down at about 40 degrees. The aircraft, with no corrective input stabilizing it, plunged into the open field near Great Hollingbury. The impact was catastrophic. The Boeing 747, mighty, resilient, was destroyed. All 4 crew members died instantly. The
Look at the structural fatigue
AAIB
here.
identified multiple
The explosion
causal
must have been
factors.
centered right-
Instrument fault misdiagnosis. Engineers fixed the ADI but left the faulty INU uncorrected. Captain's reliance on faulty data. Despite warnings, the captain trusted the incorrect ADI. Poor crew resource management. The first officer did not challenge the captain's actions, even when his own instruments showed the truth. Lack of cross-check culture. The flight engineer's repeated warnings were not acted on in time. The accident report was clear. This was not a case of a single mechanical failure. It was a chain of human and systemic failures. Investigators highlighted deeper issues rooted in crew hierarchy and culture. Communication was poor, and the cockpit lacked a truly collaborative environment where less senior crew felt empowered to intervene or challenge the captain's decisions. The AAIB recommended comprehensive changes. Improved crew resource management training tailored to cultural and operational realities, better maintenance procedures and fault verification protocols at remote stations. The accident became a case study in how human factors and organizational shortcomings can be as dangerous as any mechanical defect. Today, Korean Air has overhauled its training programs, increased cross-checking emphasis, and strengthened communication protocols. The tragedy remains a stark reminder. A single instrument error left unchecked can destroy even the largest aircraft if human and procedural safeguards fail.
Learn more about aviation safety. Subscribe for more investigation videos.